Hey, good morning, everybody. Welcome again to a session of Joe with Joe. I'm here with my good friend and colleague, Joe Johansson. Joe, thanks for being with us this morning. Our wrap-up session. It's been quite the journey over the last 10 sessions, covering a whole multitude of different fundamental topics. We started this series back in March and have progressively worked through the series of topics, like I said, over 10 sessions, and have arrived here at our culmination.
Good to see you all here again today. And today we're going to try to wrap it all up. And I have my favorite truck model here, and we are going to talk about how power from the engine flows down the driveline, down to the axles, and down to the wheels. So we're going to cover all the elements along the way. And I will be using this truck model here, which I like very much, to illustrate some of those points. So fire away, Justin.
Sure. In our opening sessions, we ran over 3 consecutive days, and we had focused our content at that time, particularly around work trucks. Those sessions coincided with the Work Truck Show that was in Indianapolis. Of course, this year's was a virtual event, but it was actually happening a week later. So our initial 3 topics, I think we looked at automaticity, looking at the differences between automatic transmissions, the old manual transmissions, and then, of course, automated manuals. We also covered off the topic of digital versus analog. We know, obviously, trucks use a wide variety of different devices, sensors, and how they communicate and relay information. And then also, coinciding with that work truck topic, we looked at power takeoff. And then our 4th session, we kind of came back to more of the fundamentals, first principle type approach, as Joe mentioned, looking at everything from an engine through transmission, driveline. How does that then get the wheels moving? And our first real topic that we tackled was force. And then we moved into power and torque, which are obviously 2 really key concepts when we consider an engine. And perhaps, Joe, that's the best place to start when we look at power and the difference between power and torque, and what that means for someone as they're perhaps considering speccing a truck, making sure a truck is rated for the performance that they're looking to achieve.
Yeah, thank you for that. And, I'm going to try to make this as practical as possible, because it's really all about how do we make a truck work, and how do we make it work efficiently and effectively in whatever application we put that. And whether it's a chassis that looks like this, or whether it has a dump bed on here, or whatever it has, fundamentally, it's the power of the engine to the wheels. So we can talk about that, and we can start right with the engine here. And we talk about the power and the torque of the engine. I believe we should really start with torque, because torque is the measurable feature of an engine. You can measure torque. It's a twisting force on the crankshaft. As the piston is forced down and the crankshaft is turned, we have the force and the distance creating the torque. And from that, we calculate power, because power is torque times RPM divided by 52. And that seems like a strange formula, but power is related to torque and speed. And so we can only get to power by knowing what the torque is. And we calculate power from that.
Just to touch on that, I know one of our other topics that we talked about was engine sweet spot. And so as you kind of relayed the formula there, that we calculate power by torque multiplied by speed or RPM, obviously the engine speed sweet spot plays heavily on that, and how we multiply torque with a downsped engine. Some of these things, we have some limitations as to how fast you turn an engine. So then obviously torque being the key thing that we can multiply there to then generate and influence power and put it at the wheels.
You're absolutely right. And torque is really what we use to get the vehicle moving and at very slow speeds. And then power is the aspect of the performance of the vehicle that's used at cruise, because we want to have high power at the cruise speed of the vehicle so we can sustain the momentum of the vehicle. But see, torque is really essential to get the vehicle up and moving. And we want to have high torque at about 900 RPM to 1,000 RPM, because that's where the clutch engagement speed is. And if you have low torque there, this truck struggles to get moving. And gradability and startability is so important in a heavy truck. So with modern engines providing high torque at low RPM, 900 to 1,000, 1,100 RPM, and then providing power at between 14 and 1,600 RPM, so that you can cruise down the road without having to shift gears multiple times, because it's sustaining that power.
And I know throughout our sessions, we have also looked back on the history of a lot of these topics, and perhaps it's appropriate to also mention and recognize some of the significant leaps and bounds that have happened from initial internal combustion engines to the engines we have today. It's just, when you take a look at that progression and that history, it's quite astounding how far we've come.
It is amazing, because I remember driving trucks. The first truck I drove was an International F210D with a Cummins NTC 335 engine back in the early 70s. And you had to really rev that engine to get power out of it. But today we have power available at low RPM, hence this idea of having downsped engines, because you want to be able to cruise at a good engine RPM where your sweet spot is and where your maximum power is available. And it's changed everything from the way it was. And of course, turbocharging and the control, digital controls of fuel injection has really changed all of this.
Yeah, you mentioned something there, Joe, in terms of maximum efficiency. And really that is what the significant improvement has been, talking about how fuel is managed. I know, something that's ever changing when we look at commercial vehicles and indeed in passenger vehicles. We've heard a lot within the last 2 years about electrification and electric drivetrains, and some of our sessions have introduced that idea. It is ever changing and advancing. Perhaps we'll move along. The transmission, obviously, it plays a big role in terms of developing that torque, multiplying it, and getting it to the driveline.
Well, you may ask yourself a very, very fundamental question, which is, why do I need a transmission? If you have an electric drive, you certainly don't fundamentally need one, but sometimes 2-speed or maybe even 3-speed transmissions are used to optimize the power flow. But in a diesel, because the power and the torque is really only available at maybe 600 RPM or so. And to be able to keep the engine in that range, you've got to have a transmission which allows you to shift up and down to maintain the speed within that range. So we have a different kind of transmissions. If you're an old-time driver, you use the manual transmissions, which were 13 speeds or maybe 18 speeds. And I certainly never drove an 18 speed, but I did drive 13 speeds, and they have counter shafts, single or double counter shafts. Here's the fundamental thing about a manual transmission. As you make the shifts, you depress your clutch, and momentarily the power flow to the wheels is interrupted because you have to change your gears being stationary. And so there's momentarily you lose that power. And then we have automated manual transmissions, which do the job automatically. They are electronically controlled, but they have pneumatics which shift the gears. But they still have that issue of a momentary interruption in the power flow. Now, if you're driving along a paved interstate road at high speed, that momentary interruption is negligible. It really doesn't affect the performance of the vehicle at all. But if you are on a very difficult road, maybe you're on a logging road and it's muddy and dirty and you've got a hill, you are really very careful not to make a shift on the grade in the mud, because you can lose that momentum and your wheels will begin to spin and slip. So there is another transmission, which we of course know about, which is the torque converter automatic transmission. And it makes full power shifts. There is no interruption. And there is a good reason why military forces use fully automatic torque converter transmissions, because they can negotiate the most amazing, difficult roads, and they can make that shift on the fly. So those are automatic, fully automatic torque converter transmissions.
Sure. I know you touched on, the role of gears play, and I know that was certainly our 10th session where we covered off gear ratio and we looked at multiplication through gear trains, the role that teeth ratios plays, the different gear sets that are cut, and also a little bit on the history side there. Obviously, because we're now focusing a little bit on transmission, perhaps we should also cover off the gears and how they transmit power, how they multiply power. I know in our 10th session, like I said, you had provided an outstanding example of how transformation happens. I think, you started with an engine that was capable of outputting a certain amount of foot-pound of torque, and then multiplying that to the back wheels at an astounding ratio of something around 50-1. So gears certainly are a key element when we consider that as a fundamental part of the transmission.
Yeah, gears are really many types of gears. There are spur gears, there's straight spur gears, which are simple and lower cost, but they're noisy and so forth. And then there's a spur gear where you have the helical gear cut, which allows a higher transfer of power and torque, but it also creates a side thrust. So you've got to be careful of it. But they're also have less noise. And then, of course, there's bevel gears, because what do gears do? Gears change speeds, and in changing speeds, it changes torque. But then there are also gears which change the direction. And bevel gears, for example, is used in the differential of hypoid diffs, where the power flow goes through a 90-degree directional change, is vitally important. Every truck needs that, whether it's electric or whether it's a diesel. Now, of course, there are electric trucks which have an inline motor system, but many also require that 90-degree turn.
Yeah, sure. The change of direction is very key, and will continue to be so. looking at that, we've kind of touched on engine, transmission. If you look then at the output side of the transmission, I know at our ninth session we talked underneath the body of a dump bed, and we were actually covering the topic of vibration, but we kind of used the example of a driveline to cover some of those effects. And as we move out of the transmission and into the driveline, it kind of is the next element for how we transmit that torque and power to the wheels. So perhaps, Joe, we should break down a little bit the effects of happening at the driveline, both vibrational and then how the driveline itself is performing.
I really need to go back one step. Because this is fundamentally important about gears. I'm sorry about having to go back, but that's important. We should not forget that if having multiple gears, and it's as simple as this, if the speed of the output gear slows down, the torque goes up. Now, to get back to the drive lines, yes, drive lines are important in order to move the power from the output of the transmission to the differential. And that is done through a drive line. And the drive line, as we all know, being truckers, is the drive line here. And it consists of sometimes multiple pieces. Now, the interesting thing is it has U-joints, and any mechanic or truck guy knows about a U-joint. It's also called a cardan joint. And the interesting thing about this cardan joint, because the drive line is not perfectly straight, it goes through an angle. And for the power to flow and the torque to flow through that joint, it uses this cardan joint. And it causes the driven shaft to accelerate and decelerate. So as it's being rotated, it decelerates and accelerates. And that causes a potential vibration. If the input to the shaft and the output are at the same angle, they cancel out. But if we have a slight change to the drive line coming out of that joint, then there is this acceleration and deceleration. And that can cause potential vibrations, especially if that angle is larger than 3 degrees. So you have a potential for vibrations. And there are 2 of those vibrational impacts per revolution. So we call them second order. And so if you have a problem and you discover that there's a second order vibration, then it is very probably due to your drive line. The drive line.
In the drive line, some slight misalignment in the drive line, rotating a mass at high speed and a slight imbalance will cause of that vibration and become a major issue.
Yeah, and do remember that problem asserts itself whether you have a remote-driven hydraulic pump from your PTO and you have a drive shaft. That potential problem exists right there as well, and also the interaxle drive line between the tandem axles has the potential for that problem to assert itself as well. So we have to be very careful about these vibrations, which can be very damaging to the transmission.
Sure. And I guess we talked a little bit about the effect of an operator or a driver and how that changes their feeling or their feel as they're driving a vehicle, vibration that starts in the driveline, how it's transmitted to not only wear components and ultimately result in failure, but also be a discomfort for the driver. I know obviously the driveline ends at an axle. We touched a little bit on interaxle driveline. Perhaps, Joe, you could jump into some detail on axles. We talked about the role of gears and changing directions you get out of the driveline from the transmission through a cardan joint or a series of cardan joints through a differential, which is changing direction at your axle.
Sure. Most trucks, and I'm saying most, certainly internal combustion engine trucks with a normal architecture, and I'm saying normal because everything that we've learned in trucking for the last 100 years really is normal. The engine, the engine, transmission, driveline, and then the axles, which of course has the potential now to change with electric axles, that some of them which do not require differentials. But any internal combustion engine powered vehicle with a transmission and drivelines has high-poid differential axles, where they have a crown and pinion, which changes the direction, that bevel gear. But there are some also which have planetary gears. And a planetary gear is a planetary set of gears in the hub of the driven wheel set. And this can be used in very heavy-duty trucks to bring the overall axle ratio way up to in the 10s, 12s, 14s even, which is far greater than what you would have the ability to get just from the differential.
I guess now probably is an appropriate time to kind of loop back to forces. I know as we've moved from engine to transmission, driveline, differential in the case of an internal combustion engine along the axle, we now have some motion at the wheel. And our first topic out of the work truck show was looking at force and some of the elemental reasons and first principles of force. So now we have a transmission. There are some forces that we have to overcome, obviously throughout the driveline, but now we have power at the wheels. Talk a little bit about some of those propulsion forces and the things that have to be overcome to continue to move down the road.
Yeah, thanks for introducing that. There are really three forces which have to be overcome to make a vehicle move down the road. And the one is grade resistance, and that's the force that inhibits the vehicle moving up a grade. And of course, the steeper the grade, the higher this force is. And then there's the air resistance, which is another force that essentially holds the vehicle back. And then there's rolling resistance. I want to talk about those a little bit because many truckers, and I've heard truckers say, you know, I can drive my truck up a very steep grade at high speed because I have a super duper truck. Now, I have to try to bust that myth right here and now. And let's take a grade, for example. The steepest interstate grade is around 6.5%. And the grade that I know, any trucker who's been out west knows the road between Breckenridge and the Eisenhower Tunnel. That's about 6.5%. And I had a guy tell me once, you know, I can drive up that grade in my older model truck because it doesn't have any of the modern stuff that hangs onto it, and I can drive up there at 60 miles an hour fully laden. And I had to say, I had to bust his bubble right there and then. And I can show you some numbers here. For example, to drive up a road with, I had the numbers calculated here, so I have to read them off because I haven't memorized them. The power to move an 80,000 pound vehicle up a 6% grade, in other words, from Breckenridge up to the Eisenhower at 60 miles an hour is 769 horsepower. But for the guy to say, well, I can do it at 70, that would require 897 horsepower. And there is really no standard truck today which is able to have that power available at the wheel, because this is wheel power. And so this grade resistance is a very fundamental thing which every driver knows. I cannot get up that hill at the speed that I'd like to, because the grade is just too steep. Now, an interesting thing is it's all related to speed and, of course, grade and the load. So here's another thing. If I had a 400,000 pound load and I was putting it up at a 6% grade at 10 miles an hour, not 60, but 10 miles an hour, I can do it with 640 horsepower. So you see how it's related to speed and load. And so this is very important as we talk about grade resistance. Now, the other one that you mentioned that we talked about there, Justin, was air resistance, right? And air resistance, of course, as we all know, is the flow of the air across a body like this. And a truck like this with big rear view mirrors and air cleaner tanks out here and so forth has a very high resistance factor to air flowing over it. And the thing to remember here is that the power absorbed by air resistance is to the cube of the road speed. The power is to the cube of the road speed. And again, I made another calculation here. An 8x13 box truck at 60 miles an hour with an air resistance value CD of 0.7, which is maybe a little bit high, but it's the best I have, at 60 miles an hour requires 104 horsepower to overcome that air resistance. But at 70 miles an hour, just 10 miles an hour more, requires 177 horsepower. So the power is related to the cube of the speed. So the faster you go, the higher power is absorbed to make it move through the air. And the final one is rolling resistance. And the power absorbed by rolling and squirming of the tire across the road, which is, of course, related to the weight, the imposed weight on a tire, and then the road surface. So those are the three forces.
I think, Joe, you kind of captured it pretty well there with some of the calculation examples and the horsepower required at the wheels. And when you consider that against the power or horsepower that's available at the engine, it is quite the difference to the, when we consider that as an efficiency, we're often talking about an approximate ratio of maybe 30% of engine power is actually available at the wheels, overcoming all of those things. So we have losses through all facets of the drivetrain, and then you get to the wheels and you have to overcome some additional forces. It's not quite done yet. And it is quite astounding in terms of the losses and those parasitic effects that force plays.
Yeah, it is kind of amazing when you think what goes into speccing a truck and how do we come up with the most efficient vehicle. And so we've got to have the right engine producing the power and the torque at the right speeds. But we have to remember, we have to understand how the vehicle is going to be used. What speed do I want to cruise at? And then the type of transmission I want to use, and then the driveline, and then the axles, so that we come up with a system that provides me with adequate wheel power at the right speed. So important.
Absolutely. I think we've covered a lot of fundamentals. We've obviously touched on all of these through 10 different sessions. Joe, I know that all of your content is available. In addition to what we've covered here, you have a couple other fundamental topics. Maybe you can go ahead and introduce that both as an availability to everyone that's taken in the series and as an ongoing education.
Well, I have this truck series of the fundamental aspects of a truck available on a website called Teachable. And you can get there by going to truckfundamental.teachable.com. And there is a slide coming up here, which you will see, which has address. There's a QR code. You can get in there. And I have a special, I've got to sell something, right? The special right now is that there's a 50% discount if you go and purchase this. So this takes you through the whole gamut of the fundamental aspects of a truck, right from power and torque to the digital controls, to power takeoffs, and so forth. And it is not a course that teaches you how to repair things or how to work with stuff. It gives you the fundamental aspects of this technology, which I believe makes you a better truck salesman, makes you a better driver, makes you a better fleet operator, and a better purchaser. Because if you understand the fundamentals, it gets you where you want to go.
Absolutely. It's a great resource. Some of the additional information that's available there includes quizzes, some in-depth discussion topics that kind of goes a little bit further than what we've presented in our sessions. I feel like we're basically scratching the surface. It is an outstanding resource for anyone that would like to make the investment. And like Joe said, it's suitable for everyone that's operating in the industry, whether it be from sales to a driver, a fleet manager. It's an outstanding resource. I'll wrap up and say thank you, everyone, for joining us again. Joe, it's always a pleasure. I'd like to thank you for your continued effort. Our 10 sessions have been great, and getting to talk it through in some more detail today, it's been great.
Thanks, Justin, and thanks to everybody out there. And I hope you found it useful. And please go on trucking.
Thanks, everybody. Bye.